Hi, I am Anar, third year petroleum engineering student. Today I am going to talk about time-independent non-Newtonian fluids. In this presentation, the content is introduction, and I will classify non-Newtonian fluids. I will explain their properties and give some examples, and after that conclude all material that I covered. Let's begin. As my group mates explained that there are two types of fluids as Newtonian and non-Newtonian. All gases and lightweight liquids considered as Newtonian because their viscosity doesn't depend on shear rate and this viscosity is constant. But in the case of non-Newtonian fluids, viscosity is being changed and it varies with the time and shear rate, and it is not constant. And to define meaning of time independent, we can say fluids for which the shear rate at any point is determined only by value of shear stress at that point, at that instant, and these fluids are variously known and time independent. As I explained that there are two classification of time independent non-Newtonian fluids. One of them is you can see set of plastic fluids or shear thinning, dilatant or shear thickening, and Bunsen plastic. So the plastic fluids or shear thinning fluids where apparent viscosity decreases with the increasing of shear rate. You can see here is a graph that shows us diluent fluid 3, Bunsen plastic 4, Newtonian fluid 1 that passes through origin, and this is linear, and 4 Bunsen plastic. And this is a graph that shear stress and shear rate show. And in pseudoplastic type, shear stress and shear rate plots become straight line, and on a linear scale it passes through origin. You can see here the 2 point and it's a straight line. In contrast to Bunsen plastics, the plastic fluid is a fluid that increases viscosity as force is applied. If we apply force, it means the viscosity will increase. A typical example of is a suspensional cornstarch in water with the concentration 1:1. As you know, this cornstarch behaves like water when no force is applied. But however, it is solidified as force is applied. The second classification is dilatant and shear thickening fluids. Dilatant or shear thickening fluids where apparent viscosity increases with the increasing shear rate, and quicksand can be example. You can see here dilatant fluids as number 3. Here's a plot of this. At first it seems solid, but as victim walks on it, thereby applying stress and causing it to become more viscous, they sink in that as they struggle. And the last classification is Bunsen plastic fluids, where certain shear stress is needed before fluid starts to flow. The best example of can be toothpaste. We use it daily life. And before we apply pressure, it is like solid, but if pressure at the wand of pipe is increased, this produces stress on fluid, tending to make it move. This is called shear stress. And volumetric flow rate increases if you apply pressure to force to toothpaste. You can see it acts like a liquid. And this uh, And however, for Bunsen plastic, stress can be applied, but it will not flow until certain value, which is yield stress reached. Bunsen plastic is labeled as 4, as you can see from graph. And after that, we can give example. And here all three Newtonian fluids are plotted in diagram. Also included is a Newtonian fluid, and can be example of water or acetone. Here some example is shown. For the example of plastic, engine oil, shampoo, we use it daily life. You can see here a picture. Tilted or shear seeking quick stance. You can see here it's like it looks like solid, but when victim walks on it, it sinks. And but for Bunsen plastic, there can be example toothpaste or hand cream. You can see there's a picture. And after that, for conclusion, for that diagram, all four types of fluid just happen to pass through the same point. You can see here is a point. At this point, they all have the same apparent viscosity mu. The ability to obtain good physical properties such as viscosity from the experimental results or correlation is an important aspect of engineering science. At the end, to conclude, we can say for pseudoplastic fluids, viscosity decreased with the increasing of shear rate. For diluent fluids, viscosity increasing with the increasing shear rate. For Bunsen, shear rate needed before fluid starts to flow. Thanks for attention. This was my presentation of time-independent non-Newtonian fluids. See you.